This is the lecture about how to verify that the given function is the solution of the given differential equation. And the second thing we have to finding an appropriate interval I of the definition for the solution. The first is question number 1, verify the function. That function is y equals to e power minus x over 2 is a solution of the differential equation to y dash plus y equals to 0. Now, firstly, the differential equation will be given and its solution is also given. So we have to check that whether this y equals to e power minus x over 2 is the solution of the given differential equation. Now, how to find that? We are going to first find the first derivative, the derivative of this, so that we can substitute in the given differential equation. So in order to get the derivative, we will take y dash equals to e power minus x over 2, take its derivative with respect to x, so it will be e power minus x over 2. Again, take the derivative of minus x over 2, it will be minus 1 over 2. So minus 1 over 2, we are going to write it over here. Now substitute the value of y and y dash in the given differential equation. The given differential equation is 2y dash plus y equals to 0. So after that, we are going to substitute the value of y equals to e power minus x over 2 and y dash is equals to minus 1 over 2 e power minus x over 2. So this is y dash. After that, just simplify the equation. So it will be 2 and 2 will be cancelled out. So we will get minus e power minus x over 2 plus e power minus x over 2 equals to 0. If the left hand side comes equals to right hand side, this means that the given equation y equals to e power minus x over 2 is the solution of the given differential equation to y dash plus y equals to 0. But if left hand side is not equals to right hand side, then we are going to say that it is not the solution of the given differential equation. But now here, since left hand side is equals to right hand side, so this means that the given is equation y equals to e power minus x over 2 is the solution of the given differential equation. The second thing we have to find is finding an appropriate interval I of the definition for the solution. How to find this appropriate interval? We have to find first, we have to find the domains of y and y dash. So we have to find the domain of this function or this solution y equals to e power minus x over 2. That domain is whatever the value we substitute in x, it must give us a definite value of y or the real value of y. So we can see that whatever the value of x we put here, okay, whether we put 0, 1, 2, 3, any value we put, so we will get a definite value or a real valued function. Y will be a real valued function. So this means that the domain of y is going to be equals to minus infinity to infinity. That any value we can substitute, we will get a real value. We will not get this as a undefined value or the function. So this means the domain of y is minus infinity to infinity. Similarly, we have to see what will be the domain of the derivative y dash. So the domain of y dash will be equals to minus 1 over 2 e power minus x over 2 is also minus infinity to infinity. Since we can see the function is almost same for the y and y dash, so this means that whatever the value of x we substitute here, 0, 1, 2, 3, any value we substitute here, we will get a real valued function or real value. So this means that any value we can substitute from minus infinity to infinity, we will get a real valued function. Means that we are not going to get any undeterminate or undefined function, or we are not going to get any complex number here. So for if both of the domains are same, then the interval I of the definition for the solution will be minus infinity to infinity. Since both the domains are same, so we will say that this is the interval of definition for the solution. But if they are different, then we will see the other case in the second example, that if their intervals are different, then what will be the domain or what will be the interval of definition for the solution. So in order to check that case, we will do this question number 2. Verify that the function y equals to x plus 4 into square root of x plus 2 is the solution of the differential equation, which is given as this y minus x into y dash plus y minus x plus 8. The first step in order to find that it is the solution of the given differential equation is that we have to find the first derivative. Okay, we are supposing that this is the solution. So in order to prove that it is the solution, we have to take the first derivative of the given solution. So when we take the first derivative y dash for this, so we will get y dash equals to x. So we are taking with respect to x the derivative of y dy by dx. So the derivative of x with respect to x will be 1. And what will be the derivative of this? This is 1 over 2. So 1 over 2 will be coming over here, and 1 over 2 minus 1. So to take the derivative of exponents, it is just the rule. So it will be coming to 1s are to 2s are, and this will be x plus 2 having the power of minus 1 over 2. So the answer will be 1 plus 2 over x plus 2 square root. So this is the first derivative or the derivative of y. Now we are going to substitute the value of y and the value of y dash in the given differential equation. So this is the given differential equation. And we are going to check that by substituting the value of y, by substituting the value of y dash, do we get the left hand side equals to right hand side? So we will substitute now the value of y and y dash. In the given, this one is a given differential equation. So y, since we know y is equals to x plus 4 into square root of x plus 2, this is given in the question that this is equals to y minus x same, then y dash. Y dash is the derivative we have just find out. Derivative of y is 1 plus 2 over square root of x plus 2. It is equals to y. Again, the value of y is same as we have written it over here. Minus x plus 8. Now we simplify this both sides so that to check that whether the left hand side is equals to right hand side. So here we have to see that this is x plus x, this is minus x, so this and this will be cancelled out. So we will left with just this term, 4 into square root of x plus 2. Multiply by 1 plus 2 over x plus 2. After that, we can take what? We can just take or multiply this with this, and we can multiply this with this. So we get 4 multiplied by this all with 1. So we get 4 into x plus 2, and this term multiplied by this. So we will write it over here, and this term will be writing over here. And after that, 4 into square root of 2, x plus 2 plus 8. After that, more simplification we do, like we can cancel this with this. So we will left with just 2, okay, and 4. So 2 into 4 will be 8. And this will be same 4 into square root of x plus 2. So this is same. Now, if we see the left hand side and if we see the right hand side, they are all same. So this means it's the left hand side. If we get equals to right hand side, this means that this y equals to x plus 4 into square root of 2 plus x is the solution of the given differential equation, which is given as this. So after proving that it is the solution of the given differential equation, the second part we have to find the appropriate interval I of the definition of solution. So since we have proved that is the solution of the differential equation, now we have to prove or we have to find the interval I. In order to find the interval I, we have to find the domain of y and domain of y dash. Okay. So we can see it over here. What will be the domain of y? So we have to check what will be the values of x we substitute here so that we can get a real valued function, that we must not get any complex number or we must not get any undefined number or undefined function value. So we can see that we should not, or we cannot put here -3. Okay, we cannot put the values which are less than -2. Okay, the values which are less than -2 means -3, -4, -5. If we put it over here, then this becomes the square root of -1. So square root of -1 will be a complex number. So this means it will not be the domain. So this means that if we put here -2 or -1 or 0, 1, 2, 3, we will get a real valued function. So this means that x, the range of x will be starting from -2 to infinity. And after that, we are going to see that it will be -2 to infinity. So we are going to get the domain of this function y. It will be equals to -2 to infinity. The domain of y dash now, we have to check again that what are the values of x we can substitute here so that we can get the real valued function. So how we get the real valued function? We can see the same thing, that if we put here -2, we are going to get 0. But 2 over 0 will make it undefined function. That anything or any number, any integer divided by 0, it will be undefined function. So this means that -2 we cannot put, and the lesser values of -2 means -3 also if we put, we will get a complex number, and -4 also. But we can put here -1, 0, 1, 2, 3, any number. Okay, we can put here other than -2. So we will get the real valued function. So this means the domain of y dash will be equals to -1 to infinity. Okay, so -2 must not be included in this, because if we put here -2, it will become an undefined function. So this means now the domain of y and y dash, we can see they are different, because in the first, the domain of y is -2. -2 means that -2 is included, it is the closed interval. But here it is open interval, that -2 is not included. Now they are having different domains, so we have to choose that interval which satisfy both y and y dash also. So how to choose y and y dash? We are going to say that if we put here -2 as the open interval also, this will satisfy the equation, or this will satisfy this function also. So this means that -2 and infinity satisfy both the functions, y also, y dash also. So this means the interval of definition for the solution is -2 to infinity. Why we are not putting -2 as a closed interval? Because here -2, if we put here closed, and if we put here -2 value, then we will get undefined function. So this will be satisfied by this, but -2 as a closed interval will not satisfy this function or this domain. So this means that the interval I of the definition for the solution will be if we select -2 to infinity as a open interval. So this is how we are going to find the interval of definition for the solution. Now question number 3 is also similar. So verify the function y equals to 1/4 minus x square is the solution of the differential equation y dash equals to 2x y square. How to find the solution of this differential equation? The solution is already given, but we have to check whether this is a solution or not. In order to show that y equals to 1/4 minus x square is the solution of y dash equals to 2 of x into y square, first we will take the derivative of y. So the derivative of y we will take as, first we will take this term as a -1 because it is in the denominator. When we take it the numerator, it becomes -1. And then we take the derivative. The derivative will be -1 will be coming here. And then here -1 and -1 becomes -2. And again we take the derivative of this. base function, so it will be minus 2x. X square's derivative will be minus 2x, and we can write the function as 2x over 4 minus x squares whole square. Now we are going to substitute the value of y and y dash in the given differential equation. So the given differential equation in the question is this: y dash equals to 2xy square. So just substitute the value of y dash. Y dash is this: 2x over 4 minus x square whole square equals to 2x into y square. Y square is this: 1 over 4 minus x square whole square. After that, if we take the square, so the square of this becomes here square of 1. 1 square is 1. So 1 multiplied by 2x will be 2x here. And this becomes the whole square of this. So we can see that the left hand side is exactly equals to right hand side. So this implies that y equals to 1 over 4 minus x square is the solution of the given differential equation. So this is how we are going to show or prove that the given equation is the solution of the given differential equation. Now, in order to find the appropriate interval I of the definition for the solution, we have to find what? We have to find the domains of y and y dash. So in order to find the domain of y and y dash, we are going to see first y, that what values of x we will substitute so that we can get a real valued function. We must not get an undefined function. We must not get a complex number also. So we have to see and we have to check. So if we substitute here that if the value is minus 2, if we take its square, so it becomes 4, and 4 minus 4 is 0. So this means that it will become an undefined if we put here minus 2. So this means that we cannot put minus 2 here because it is making it as an undefined function. But we have to check whether we can put 2 here. And if we put here 2 also, 2 times 2 is 4, 4 minus 4 is 0, then it is again an undefined function. So this means that excluding 2 and minus 2, but any other number we can put, like 1 also we can put here. So 4 minus 1 is 1, or minus 1 also we can put, 3 also we can put, minus 3 also we can put any number, but just we cannot put minus 2 and 2 because it is making this function as an undefined function, 1 over 0. So this means the interval or the domain of this function will be minus infinity to minus 2 as the open interval, then minus 2 to 2 as the open interval, and 2 to infinity also as the open interval. So this means the domain of y will be these intervals. Similarly, we have to find first the y dash. Y dash we have already found that 2x over 4 minus x square whole square. So this means that we have to again see for the values of x, which values of x make it as a real valued function. We must not get an undefined function or a complex number. So we will see again that if we put here minus 2 or if we put here 2, then this function will be undefined. So this means that what will be the domain of this function, that we can put any value between minus infinity to minus 2. Minus 2 is not included, but minus 3, minus 4, minus 5, minus 6, any value we can put, we will get a real valued function for this. So that is the domain. And also between minus 2 to 2 and 2 to infinity also, between any number 2 to infinity means we can put 3, 4, 5, 6, any number, we will get a real valued function. So this means that the domain of these both y and y dash are these three different intervals. So since they are same intervals, we can see, so the domain, we have the interval I of the definition for the solution is all the three intervals, minus infinity to minus 2, minus 2 to 2, and 2 to infinity. So this means in this question, we can get three different types of interval I. There is not a single one. we are having three different interval I for the definition of the solution, that because they are the domain of y as well as y dash. So it is not necessary that the interval will be just one or interval is same for y and y dash. So these three different examples show you that in the first example, the y and y dash have same intervals or domains. So we say that that is the interval I of the definition of solution. But in the second question, they have different domains. So we have to select that domain in question number 2, which satisfy both y as well as y dash as their domain. But in the third question, we can see we have different intervals, three different intervals, which are the domain of y as well as y dash. So we consider them all. Okay, so any of them can be the interval I of the definition for the solution. So this is all about how to find that the given solution is the solution of the given differential equation, and how to find the interval I of the definition for the solution.